This is part 2 of the MQTT publish subscribe communication tutorial using OpcDbGateway. In this video, we'll show you how to sign in to receive messages with a given topic from MQTT broker and how to store these messages in OpcDbGateway process values for further processing.
In the previous video, we've shown how to send MQTT messages from OpcDbGateway to the MQTT broker. We have shown it on a home automation system use case. Data points from this system are transmitted through an external OPC server and mapped to process values referenced by the memory operands in the OpcDbGateway configurator. These data are transformed then into the JSON strings in the OpcDbGateway runtime and sent to the MQTT broker, and from there into the applications having MQTT subscribe clients. OpcDbGateway can also mediate the transmission of messages in the opposite direction from the client applications to the home automation system. This can be used, for example, to switch on and switch off some appliances remotely. The mapping of OPC variables to data points is performed as in the previous case. This time, however, the OpcDbGateway runtime must transform the received JSON strings into process values so they can be transferred to building automation system through the OPC server. Let's recall now how we configured the MQTT publish client to periodically send JSON strings to a MQTT broker. We have used event of the type start of external program that is triggered by a periodic trigger. The starting external program is defined in the event dialog box. This definition contains a constant string that includes a path to the started program as well as command line interface parameters. The memory operands that referenced the current process values from an external OPC server were configured using the event parameters dialog box. The first step to configuring communications in the opposite direction is to select an enhancement DLL that allows us to run an external process and to process data from its standard output. To use functionality of chosen enhancing DLL, we have to configure configurable command call DLL, and before that to set input parameters using other configurable commands. Enhancing DLL provides then starting of external process of the Mosquito subscribe client. It will continuously receive data from its standard output to process image values for next processing. The configurable command call DLL has, as every other configurable command, two input parameters. The configured name of DLL. It can differ from DLL file name. Then the first memory operand from the array of input and output arguments. The length of the input and output arrays is defined in source code of the enhancing DLL, and information about it can be seen in configurable by configuring enhancing DLL itself. Return value of the command is true or false and informs if the configurable command has been fulfilled successfully or failed, for example, because of not correct values of arguments. The meaning of values of input and output arguments is following. MO actual status, this is status whose value 1 to start and value 2 to stop the child process. MOCLI string is memory operand referencing of process value for command line interface string to start the child process. MOIndex for child stdout string is memory operand referencing of process value for placing of string from standard output of the external process. MOIndex for new stdout notification is memory operand referencing process value for notification that a new string is available from standard output of child process. It is used also for communication handling between OpcDbGateway runtime and continuously running enhancing DLL. MOLOG from do process IO. This is memory operand referencing process value with information about error in arguments configured for call DLL command. Let's discuss the functionality using sequence diagram. The OpcDbGateway runtime starts the new thread from DLL immediately after its own start. It performs it by the DLL API function on start. The new thread waits in the loop for the do process IO DLL API function call. This function is called by the configurable call DLL command. In the call to this function, arguments are handed over. In our case, for example, command line string for the Mosquito sub exe, including parameters as the host for MQTT broker and topic of messages that we want to receive. After uploading the arguments, the child process is started and it waits for telegrams from MQTT broker. Communication between the OpcDbGateway runtime and the enhancement DLL runs throughout the application run through process values. The communication between the child process and the thread in the DLL runs through an unnamed pipe. Upon a receipt of the message from the MQTT broker, the notification is sent in one process variable and the telegram itself is transmitted in another process variable. Runtime uses the notification to trigger an event of the type call function block to provide the message processing. Runtime also makes a reset of the notification to inform DLL that message has been processed and the next one can be received. In our application, messages are also written to the log file via the standard logging class in the enhancing DLL. Stopping the child process is done by the call DLL by calling the do process IO API function with the MOActual status argument set to stop value. This call is within OpcDbGateway runtime provided by the event of the type call function block. This will stop receiving messages from the child process, but it usually not provides its removing from memory. Prior to OpcDbGateway runtime termination, it calls the do process IO again, with the MOActual status set to stop. It is done within the standard stop function block. The child process is then definitely removed from memory. Just before the OpcDbGateway runtime stops, the DLL API function on stop provides ending of the DLL thread. Let's see how it is configured and how the two-way MQTT communication application works. The first part of the application is basically the same as the application for sending messages to the MQTT broker. We have used the configurable event type starting an external program, which started the console application Mosquito pub, which has secured the transmission of telegram in JSON format containing current process values referenced by the memory operand selected in the Event Parameters dialog box. Let's see how the MQTT broker is configured to receive messages. In particular, we need to configure the enhancing DLL to start the external process, to receive messages and to store them in process values. We will select the DLL by file name and name it in the configuration. Note that there are information about the number of input and output arguments which are stored in the continuous array of process values. Functionality of the DLL is initiated by the configurable command call_DLL from the function block. The call_DLL command has 2 input arguments and 1 output, as well as other configurable commands. The first input parameter is the configured DLL name, and the second is the first memory operand from the continuous array of input and output arguments. An unsuccessful call could be caused, for example, by incorrect setting in the argument field. The function block contains also setup of the values in continuous array of input and output arguments. There is, for example, command line string to start process mosquitoes pub exe. Let's explain the structure of the entire application. The application contains the standard function block start and function block restart that we will use when initializing variables and calling nested function block fb for call read std out child DLL. It involves executing the parameter setting and calling the call_DLL command. At the beginning, it is always called either function block start or restart, depending on whether the configuration has changed or not. We have here also the function block main, which is used for the so-called synchronous functionality of OpcDbGateway, but we do not use it in this application, and it is therefore empty. However, we have 2 function blocks initialized by value triggers as asynchronous events of the type call function block. The function block fb confirm notification from read child std out is used to send messages between DLL and the OpcDbGateway runtime received from the MQTT broker. Process value for notification activates the trigger that launches mentioned function block. The received message is then copied to another process value for further processing. The second function block fbStop serves to stop communication with the MQTT broker. Additionally, we have an MQTT pub event started with a periodic trigger to send messages to the MQTT broker. A standard function block stop is called when the OpcDbGateway runtime is terminated. It provides a definitive exit to the mosquito sub.exe process. Now we run the application. The OPC client configurator connects to the OPC server in the OpcDbGateway runtime. This allows us to monitor process values. We see periodic rotation O and 1 in the notification variable, as well as updated telegrams from the MQTT broker. Messages from the MQTT broker can also be viewed in the output view, where the updated log file is displayed. In Task Manager, we can see the running Mosquito sub.exe application. To stop it, we can activate trigger that call function block fbstop. We will close the application by disconnecting OPC client in configurator from internal OPC server. In the Task Manager, we see that Mosquito sub.exe has also been correctly terminated. In the previous demo, two communication channels were used between the child process and the enhancing DLL. The one is command line interface for child startup process and standard output stream plus input byte for message transfer from child process to DLL. However, this solution can be further extended by using standard input stream and the standard error stream of the child process to communicate with separate pipes with DLLs. Of course, all the child process functionality could be implemented directly in the DLL. However, the console application solution provides the opportunity to use the vast number of these applications programmed in various programming languages. In this video, we have seen receiving of messages from MQTT broker by OpcDbGateway. Second, how to start and stop continuously running external process and to save data from its standard output to process variables in the OpcDbGateway process image memory for next processing. And third, the possibility to enhance the functionality of OpcDbGateway using console applications or child processes programmed in different programming languages.
Thank you for your attention and I wish you a nice day.